Hi, welcome to my video on the definition of a secant and a tangent. A secant is a line that passes through 2 points on a curve. If a curve is linear, then the secant is linear and has the same slope or the average rate of change. So what we have is that we could have this line, and that's a secant, because the secant passes through 2 points, but it passes through 2 points. It can also pass through more than 2. Or, as linear, this is a horizontal line, and this is the secant, but the slope here is 0, because it's a horizontal line. And the slope for this one is positive, because it's going up to the right. And we also have this one. This is a linear function, but, no, this is a linear, but it's not a function because it fails the vertical line test. So this is a vertical line, which is linear, but it's still a secant. And this is a horizontal line, which has a slope of 0. This is an oblique line. I could also draw another line coming this way, and that's oblique, and the slope of this line is negative. The slope of this line is positive. So this one goes up to the left, which up is positive, left is negative, so that's a negative slope. Up is positive, to the right is positive, so it's positive slope. 0 slope, and this is a no slope, because this is a vertical line. But they're all secants, because they pass through 2 points of a curve. And I could also say a line that passes through 2 or more points, because if you got 2 points and you draw a line, you have many more points. A curve is quadratic. A curve is quadratic, cubic, quartic, exponential, etc. The slope of the secant is the slope of the line passing through 2 points of the secant, but not the slope of the curve. So let's illustrate. We have, this is a quadratic, and we draw a secant. So in this quadratic, I'll draw this secant. So this secant cuts the parabola into 2 points, but it's the slope of this line, but it's not the slope of the curve. We have a secant here. I can draw a positive secant or a negative secant. So if we draw a negative secant, like that, slope is negative. So this is the slope of the secant, but it's not the slope of the curve. Only on a linear, when you have a linear, like this, a line, the slope of the secant is the slope of the linear function. The slope here is 0 because it's horizontal, but there's no slope here. So on a linear, the slope of the secant is the slope if it's not non-vertical. But when you got a quadratic like these, so I can draw a secant here. So this is the slope of the line between these 2 points here and here, but this is not the slope of the curve. And I can draw, this is a parabola opening downward, so secant here is this one. So this is a positive slope, but it's not the slope of this curve. This is only the slope of the line or the secant between these 2 points. We have a cubic. A cubic is, one of the cubics is like this. We could have other cubics, but when I draw a secant here, so we have this, the slope of this line is, again, this is a linear, so, but it's, the slope of this line is not the slope of this curve. And we have another one, which is, it's the same shape. This is positive because it's opening up, it's going upward on the right. So we draw a negative secant here. So again, it goes through these 3 points, or any point on this line. So the slope of this secant is the slope of this line, but it's not the slope of the curve. Quartic is 4 points passing through. Like here, 4 x-intercepts. This is one example of a quartic. So notice a parabola cuts at 2. A cubic cuts the x-axis at 3 maximum. A quartic, degree 4, cuts the x-axis at 4 points. So a parabola cuts it at 2. A cubic can cut it at maximum of 3. Quartics has a maximum of 4. There's less to this if you look over the unit on polynomials. And this is an exponential curve. Oh, I forgot to draw. So the slope of this line is the slope of between any 2 points on this curve, but it's not the slope of the curve. And if we draw a secant here, there's a secant passing through the curve. The slope of this secant is positive, but it's not the slope of the curve. You'll see why I'm talking about this coming up in the next video, or next series of videos, I should say. A tangent is a line that passes through only one point of the curve. So if you've got a quadratic, a parabola, positive parabola opens upward, then a tangent line, if you take this point right here, a tangent line comes like this, and it just touches the curve at one point. Or if the parabola is going downward like this, it makes no difference if it's going downward. If you take this point right here, then the tangent is cutting through at, very hard to draw, cutting through at one point. There it is, cutting at one point. Or we could also have a quadratic in relation to, we could have probably a circle. So if we have a circle, then a tangent could be right here. Or we could have right here. Tangent is touching at one point. It could be anywhere. It could be along. It could be right here. Going along like this is a tangent. Touching it at one point. Another possibility is that we could have an ellipse. We discovered, looked at all of these conic. So a tangent here could be cutting through right here, touching it at one point. So there's many points. An ellipse is oval. So this is an ellipse. This is a circle. I'm just trying to illustrate. This is a parabola. And the parabola is opening down. So that means the A is negative. This parabola is opening up. That means the A is positive. And we got another quadratic is the what would I say? It's the hyperbola. And the hyperbola, I'll draw a simple one. Got asymptotes passing through 0, 0. And hyperbola, this one has x-intercepts, and asymptotes. And if you want to draw a tangent, we could have a tangent touching it at one point right there. Or we could have a tangent right here touching it at one point. We have an exponential. We can have a growth curve or a decay curve. Let's do a decay curve. As x gets larger, y gets smaller. So this is a decay curve. It's exponential. The asymptote is y equals 0. It's going towards, as x goes to infinity, y is going to 0. A tangent at this point is doing this, touching. There's a tangent right there. We're just reviewing different functions in relation to a tangent. We have a log, and a log got a vertical asymptote down through there, and a log, well, as it goes towards the asymptote, it gets like that, goes closer and closer, and there's a log. An exponential got a horizontal asymptote, but a log equation got a vertical asymptote. So this is a tangent at this point right here, touches right there, there's the tangent, touching at one point. And we have a square root, and the square root is the inverse of a parabola. So the inverse of this parabola is a square root, like that. So this equation could be y equals root x, Rect starts at 0, 1 gives you 1, 4 gives you 2, etc. And a tangent is touching right there. That's the tangent. And a linear function. A linear function, no tangent, because linear function has no tangent. This is cutting it at one point. When you draw a line here, it passes through many points. It's not a tangent. So that's explaining a secant, cutting it at 2 or more points. A tangent cuts the curve at 1 point. Very important. We practiced this earlier units. Label each as secant, tangent for the line A. So this is touching at 1 point. This is a tangent. Here is touching it at 2 points, intersecting at 2 points, so it's a secant. This is cutting the circle at 2 points, so it's a secant. And this can't be a tangent because it's more than 1 point, so this is a secant. Touching it at 1 point, so it's a tangent. Let's say touching, intersecting 1 point. And here it's tangent, intersecting at 1 point. So that's a review of the secants and tangents coming through the equation. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.